Hello everyone, welcome to Coders Camp. We are at 9th day of June LeetCode challenge and the problem we are going to cover in this video is Jump Game 6. So already we have solved Jump Game 7 and 2 in our channel. You can check the links in my description, and this problem is again very similar to Jump Game 7 we have already solved. So as like any other jump game problems, the input given here is also an integer array and an integer variable k. So now we have to start from the 0th index and reach the last index of the array, and the maximum steps you can take is k. So here the score is nothing but the value in the array wherever you land. So we have to return the maximum score we can get, and there is another rule given here is we have to land in exactly at the last position. We should not exceed the last position while we are stepping into our last step. So let's understand this problem with an example. So here is a given input array. We have to start from the 0th index where the value is 1. So we are adding 1 to our result. So now we have two options. Either we can land on the first step, that is first index, or the second index directly. So now if you calculate the first index with 1, it is going to be becoming 0 because it is a minus 1. But if you add the second index with 1, it is going to become minus 1, which is the lesser value. So we are planning to land on our first step. So in that case, our value is going to become 0. So now from the first step, you again have options to land on 4 or minus 7. So let us consider we are landing on 4 because minus 7 is a lesser value. So adding 4 to our result will make it 4 again. So now from 4, I again have two options, either to land on minus 7 and 3. So which will increase our value. If suppose we are landing on minus 7, it is again going to go in negative answer, and from minus 7 if you land on 3, it is again going to stay negative. But if you directly land from 4 to directly to the last index, then we have to add plus 3 to our score. So overall score is going to become 7, and that is going to be our output. So here, how are we going to approach this? So as we have solved jump game 7, we are again going to implement the same logic, a simple BFS trick, in order to arrive at our solution. So we are going to maintain a priority queue, and our priority queue is going to hold the score so far and whichever is maximum to proceed first. That is, we are going to start from the index 0 and we are going to reach the index 5. So now to reach 5, we need a maximum score. So we are going to try out all possible positions where and all we can land and pick the ones with maximum score. Starting from the 0th index, our priority queue is going to hold an integer array where the integer array is going to have the score so far and the index we landed. Obviously, the first score is going to be 1 as we are taking the 0th index. So now we have two options to land, that is from first to first index as well as the second index. So we are going to add both the scores here. The scores is going to become 0, 1 and minus 1, 2 because we are adding with 1. Then we are going to put 0, 1 first because that is the maximum score out of both, and we are going to first explore from that path and then move on to the lesser score path. So the lesser score is landing on index 2 will give you minus 1, 2. Now we have reached to the, we are iterating the given in array, and we have done with 2 indexes, and now we are at the third index. Here the maximum position we can reach from 0th index is going to be 2 because we can reach maximum of only 2 steps. So in that case, we don't have any connect from the 0th index to third index. So we no longer cannot reach any other positions from 0th index. In that case, we don't need this 1, 0 anymore in our priority queue. So we are popping that from our queue. So moving on to our next one, which is in our queue, which is 0, 1. So from 0, 1, the possible positions you can land is index 2 as well as index 3. So if you are reaching to index 2, then you will be adding minus 2 to our current score, which is 0, minus 2. So the score is minus 2, index 2. Or we can land at index 3. So the current score is 0, adding the score at 3 is 4. So this is going to become 4, 3. So out of these two, the highest score is for 4, 3. So we are going to put that first to a priority queue, and then -2 comma 2 will be entered, because we are going to pick the highest score ones first and then explore that path first. So now this is it. From 1 you can maximum reach is index 3. So we are moved to index 4, so we no longer need 0 comma 1. So next comes -1 comma 2. From -1 comma 2, that is from index 2, you have again two more options to land at index 3 as well as index 4. So now adding the scores and adding them to a priority queue will become. So yes, we can land to index 3 and 4, and the scores are 2 and -9. We again no longer need -1 comma 2. So let's move on to 4 comma 3. From 4 comma 3, that is from index 3, you can either land on index 4 or index 5. So now adding the scores of -7 and 3 with the current score of 4, then it is going to become. Yes, from index 3 we can land at index 4 and 5, and adding the scores would give you -3 comma 4 and 7 comma 5, which is actually the maximum score so far, and we have a maximum variable to keep track of these scores at index 0 every time we update with a new score, and it is going to keep track of the maximum scores so far, and that is 7 till now, and we are not yet done. We are going to still explore all the paths and pop out everything from our queue till we explore and add all possible scores from the given array. And we are going to add every possible score and explore every possible path till our priority queue becomes empty. So once it is empty, what is left here in the maximum score is going to be returned as our output. So this is it. Hope you're understanding the solution. So this is actually going to work in big O of n time, as this is a simple BFS and going to explore the given array. So yes, let's go to the code now. So yes, as I said, we need a queue which is going to hold the integer array. And we are writing a comparator that sort the values based on the score given. So we are going to store score in our 0th index and index in our second index. So it is going to sort based on the scores we add. So we have added the first index value and 0, as we are starting from the 0th index to our queue. So we generally define a variable with 0, but since this have a negative values, we are assigning the first index value as the maximum score. As we have already added the 0th index value to our priority queue, we are going to start from our first index. And as I said, if we no longer can reach to a position from some position, then we are going to pop that from our queue. And I'm going to declare an integer array current, which is going to hold the top element in the queue. And we are going to calculate the score. We are directly adding it to max because we have sorted our queue based on the maximum value or the maximum score. So whatever in the top is going to be added to the current of 0 plus the current value of our nums array. And we are going to put that back to our queue. And once all the iteration is completed, our max variable is going to have our result. So yes, this is it. Let's run and try. So yes, we need to check the index that is from 1, where we have stored the indexes of the places we land. We are checking whether we no longer can jump from that position. Then we are popping it. So let's run and try now. Yes, so let's submit. Yes, the solution is accepted. and runs in 142 milliseconds. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe, and let me know in comments. Thank you.